It does. It has to do with concavity. Okay, what does concavity mean? Which way it's curving. Okay, and I'll write that down in some words in just a minute, okay? So this means is it concave what here? Down, concave up. Okay, so this tells me, the first derivative tells me where the function is increasing or decreasing, always. Okay, or you could say where it's rising or falling, however way you want to say that. Okay, that's the first derivative, always, when you're graphing, any kind of graph.
Oh,
Okay.
that's the first graph. I'm sorry, you already
Yes,
copied it
this
down.
Okay, so this is, no, it's the part of it. This tells me concavity. Tells me if it's concave up or down. What's a way that we talk about it that's not mathematical? If it's smiling or frowning.
Okay, I'm confused. Why do we need this?
And this is what they tell us. That's what the derivatives tell us
Well,
to
yeah,
do
but-
on the graph, because we're
isn't that
graphing
what-
it.
Isn't that what Jedi just told us?
First derivative tells me where the function's increasing or decreasing, rising or falling.
Yeah, but in effect, it would also require to
No.
tell you where it was.
Second derivative tells me if it's frowning or smiling. And I'll show you in just a minute why. Okay, so
Because
we're
this
going
side's
like, because
going
you're
up
rising and then you're
and
falling.
this side is going down.
Exactly, but if the whole thing makes a frown. See, like if I go like this, I'm smiling. It's smiling, right? But it's falling and then it's rising, looking for my direction. We finished? Thank you. That's okay, that's not good. Okay, so those, all of these numbers in here are going to tell me what we said, where it's changing. We said it's rising until when x is this, and then it's falling until x is this, and then it's rising again. In the middle in there somewhere, it's changing, because 1.666 is right there, right? So that tells me that this part's frowning, so it gets to that part, and then it's smiling. You guys got that? Okay. But are these numbers here going to be at 0 on the original graph? No. So I need to find not just their x values, I need to find what else? The y values. And where do I always find the y values?
In the original.
In the original, which is where? Right there. Okay. So I'm going to take the t-chart now. So I'm going to take the points that are on my number line. I'm going to write that in words in a minute. And I like to put them in numerical order. Do you have to do that? No. It just helps me when I go to graph it. And I'm going to put those 3 values, it could be 5 or 6 values, it could be 1, substituted into the original, and that's going to be complicated unless I do what? Which question?
Do you typically do this right after you do the first derivative?
No, after the second derivative, because I need the second derivative number to go in there too. Okay, so the last step before I graph, so guess what? Guess what I still have in there though? My first one. So if I go back and highlight it and unhighlight these two, now I've got a t-chart in my calculator. Okay, so I want to go to on table ask or table auto. Table ask. Table ask always makes me a t-chart. And I like that because those are going to be kind of complicated to put in by themselves. Okay, but my y1 is my original function, so you just have to double check that you've left it in there. You can erase it and put these in and erase them each time and then go back and type it in. You can do it that way. To me, this was a nice way so then I can go back and check my work later too, and I'm not having to retype it. It's just me. Okay. So I'm going to go to my table. I'm going to type in those numbers: 0.213, 1.667, and 3.120.
Do we have all of those in there?
Okay, so there's my t-chart right there. Because I need to know what the y values are so that I can graph them. Okay?
What mode is trig calculator in?
Because it's not a trig function, it doesn't really matter, but we just keep it in radians in here. Okay, so I'm going to write some words on this one.
I'm
Okay?
confused. What function are you using here?
I'm using the original
Okay,
problem.
yeah, can you look at mine?
Yeah, just a minute,
Something's
let me
wrong.
write this here. Okay, so I take
Mine's not
all of, you might not have turned it back on, all of the numbers from the number line or slash sign charts, right? Whatever you want to call it. And put them into the original. Okay, if you unhighlight it, go back to Y2.
Oh, I see what it is now.
See what you did, okay.
Wait, hold on. Can we fix that? See, I put it as 2.13.
You just typed in the number, okay. So one thing is nothing comes up, make sure you've got it highlighted. If the numbers don't make sense, go back and check and make sure that you highlighted the right thing, that you went back and highlighted your original function. Okay? So, I took all of these and I'm putting them back into the original. Because if you put them into the individual parts, what are you going to get? If I put this into here, what am I going to get out? Or Y? If they're x-intercepts? 0. So if you get a whole bunch of zeros on your Y part, something's probably not right. Do I really need to put these in the t-chart? No, you can, but I know that that's 2, 0, negative 1, 0, 0, 8, right? I don't really need to put those in the t-chart, but I could. Okay? Got that part? Okay, so let's look at what the graph looks like. Okay, so I'm going to draw my x and y axis here. So we are drawing a specific, an accurate graph. So the first thing I'm going to do is my x and my y intercepts, and that's all I could do before. 2, negative 1, and 4. Those are the x-intercepts here of the original function. You got that? Okay. Now I'm going to put the numbers in for my t-chart. So it's a little past 0, 1, oops, I didn't do 1, 2, 3, 4, 5, 6, 7, 8. There's my y-intercept, so it's a little above that, right? So a little above that is the first point. This one is about 1.5 and a little over 2, right there. And then this point is 2, 3, 1, 2, 3, 4, a little past 3 and a little past 4. Okay, you got that part? But remember, this told me what shape it was going to be, right? I know it's x cubed. This tells me it's going to go like that, because this part here, it's frowning and then it's smiling, but it's rising, falling, rising. Okay? So until it gets to 1.6, here. Okay, it's rising until it gets to this part, right? And then it's falling until it gets all the way down to here. Okay, so this piece here to where the 1.666 is concave down, right? It's smiling. It's frowning. This one over this way is concave up, but it's still rising, falling, and rising. Okay, so now I know exactly where those peaks and valleys are. Okay, it's hard to get it straight with the marker, but it has to be pretty exact. Okay, is that what it looks like on my calculator? Is that what the original looks like?
Where is it crossing and where is it? Can you show me?
It's right there.
Yeah, I can't.
It crosses at 2, negative 1, and 4.
Okay, and where does it concave?
Until it gets to 1 point that way. See, this point in the middle. It's rising, falling, rising. So until it gets to that point in the middle, it's frowning, and then it's smiling. Okay, so the trick, the hardest part really is trying to get is to get it so you're not going, okay, because that's not right, because now I just had to change concavity somewhere, okay? Yes, ma'am.
So, is this concave down and that's concave?
Which is concave down? What?
That concave
Yes, down, it's frowning, and that's how you think about it. Concave up is it's smiling. Concave down is it's frowning. Whoever came up with that, okay. Another thing that you'll see later, this is called, and so write this in there, the points in the second derivative are called inflection points, which you'll see that sometimes. The points in the first derivative are called, sometimes they're called extremes or extremas, okay, extremes, or maximums and minimums. Okay, because notice the way this went this way, I had a relative max and then a relative min. Okay, that's just something that you will see. You don't have to necessarily have that in your head right now. Okay, all of these points on the number line, all of the points on the sign charts are sometimes called critical values or critical points. So it says, what are the critical points? Okay, and it's talking about all of those. So those are some extra little hints with the vocabulary there. Okay, so do we have an accurate graph? Yes. Did we really do anything new? No. We took a bunch of different things, derivatives, the sign chart, we know how to graph, and we put it together now and made a problem.
So, all the points on the sign chart, what is
These,
it?
this and here are the sign charts. The points that are on there, the 0.213, the 3.120, and the 1.667 go, those are called critical values or critical points, and they go on the T-chart. Okay. Yes, sir. You turn on.
Instead of finding the derivative, couldn't you just put in, like, on your graph, go to
Oh my God.
calc and do the maximum?
It's not going to give it to you exactly.